Let us compute the mean, variance, and standard deviation of a sample. Here are the formulas. For the mean, denoted by x bar, equal to the summation of the scores or the data divided by the sample size. And the variance is denoted by s squared, which is equal to the summation of the squares of the difference between the score and the mean divided by n minus 1, while the standard deviation is simply the square root of the variance of the sample. Let us have this problem. 50 students took a 40-item summative test. The scores of 10 of these students are listed below. Compute the mean, variance, and standard deviation of the scores. Now, when do we know that we are solving for the variance or mean and standard deviation of a sample? Now, in this case, only 10 scores of the students are being given here. Thus, we are looking for the mean, variance, and standard deviation of the scores. But if we are also solving for the mean, variance, and standard deviation of the 40 scores, then we are solving for the mean, variance, and standard deviation of the entire population. But in this case, since 10 students only, then we have to compute for the mean, variance, and standard deviation of the sample. How do we do that? Now, let's do it here. We list our scores in column and we label our first column as X or the scores. We have 20, 24, 25, 18, and so on and so forth. Now, we have our formulas here. To solve for the mean, we need to determine the summation or the sum of all the scores. Thus, we have to determine the sum of the scores using our calculator. And let us have 20 plus 24 plus 25 plus 18 plus 34 plus 15 plus 22 plus 27 plus 38 plus 21. And we have 244. And we input it here. We have the summation of x is 244. Okay. Now, in solving for the mean, we need to determine the quotient between the summation of the scores, we have 244, and n or the sample size. In this case, we have 10 students rather. And solving, we have 244 divided by 10 and we got 24.4. Thus, the mean of our sample is 24.4. Let us have the variance. In the formula, we need to determine the difference between each score and the mean. Thus, we label our second column as x minus x bar, and we have 20 minus the mean is equal to negative 4.4. 24 minus the mean is negative 4, negative 0.4. 25 minus the mean is 0.6. 18 minus the mean is negative 6.4. 34 minus the mean is 9.6, negative 9.4, negative 2.4, 2.6, 13.6, and negative 3.4. Now that we have determined the differences, in the next column, we need to square the differences. That is, we have x minus x bar squared. That means negative 4.4 squared is 19.36. Negative 0.4 squared is 0.16. 0.6 squared is 0.36. 6.4 squared is 40.96. Next is 92.16, 88.36, 5.76, 6.76, 184.96, and negative 3.4 squared is 11.56. We now have determined the squares of the differences. Now, in the formula, we need to determine the sum of these squares. Thus, we have summation of the squares is equal to 19.36 plus 0.16 plus so on and so forth. We got 450.4. This is now the summation of the squares of the differences. We now have the data needed to solve our variance. That is, the summation is equal to 450.4, while we have n minus 1, that is, sample size is 10 minus 1 is 9, and we have our variance 450.4 divided by 9 is equal to 50.044 in 3 decimal places. And to solve for the standard deviation, we simply determine the square root of the variance of the sample, which is 50.044, and we now have the standard deviation as 7.074. That is now, or those are now the values of the mean, variance, and standard deviation of the sample.